In this video, we're going to detail what happens inside this box, junction box. Often we call it a pass-through box. The main purpose of it is transitioning wire type. On the roof, we have our wires coming off of our modules, USC-2 type insulation, and what happens inside here is we transition to a THHN-2, some 90° C rated wire that's nylon jacketed and made to go in a conduit. So that's really all that's happening here. It can be accomplished with a terminal block. It could even be accomplished with outdoor rated wire nuts. So these are considered our home run, our home run wires, one positive and one negative. We also have our equipment ground. All of these three wires need to enter this conduit body in a watertight manner, and these connectors here are common in the industry, made by several manufacturers. But the goal is that they allow you to take wires in or conductors in free air and bring them into a conduit body in a watertight manner. So again, I've already figured out where my positive and where my negative is going to be, so I know how long these need to be. I've made them before I've gotten on the roof, and I'm just installing them now. This box is the place where reverse polarity happens more than any other place. The reason being is this wire is the end of my string for this module. It's the first string. It's going to be the positive lead of my series. This positive lead needs to connect to this connector. Here's where it gets confusing, is this connector actually says negative on it. That's the confusing part. Even though it says negative, it's the only one that mates with a positive. However, when I'm in this box, I need to keep that clear. So this is my positive. This will then be my positive, and I need to make sure that I bring this conductor to my positive, or in this case, my ungrounded current carrying conductor here. So this is the connection I need to make in here, and I'll bring the negative to the or grounded conductor to the white wire. Again, using outdoor rated wire nuts. That's all that white silicon stuff that you see. There's no power sources here. These wires are cold. There's no potential on them right now, so I'm free to work in here. Once I have these landed in here, I can then put my lockout, tag out equipment on. So just to review what's happening inside this pass-through box, I have my grounded conductor taped white to my white wire, and my ungrounded conductor to my black wire here in this case. Could be red, just cannot be white or green. My equipment ground is coming in on this bare number 6 and grounding. This is a metal box, so this enclosure needs to be grounded, and that ground will be leaving on that THHN wire as well, a nylon jacketed wire, nice and easy to pull through conduit, and rated for 90° C. These two wires that I'm connecting are the wires that will send power to my DC disconnect first, or that's the next piece of equipment that these go to, is my DC disconnect. I need to make sure there's no way for anyone to supply power to these when someone's down there. The only way I can do that is with a lockout. This is a plug type lockout. I like these because they actually can fit over our conductor here, and this is a plug lockout, and I can just fit that over my connector, and it doesn't really want to come out of there. And so then I get my lock on here, and now whoever wants to work below in that DC box where these wires terminate, they need to get this key from me and guarantee that I haven't connected PV there. The point is to keep everyone safe. Very simple protocol, and you always work on wires that have no potential on them.